All right, everybody, welcome back. This is Unit 4, and this is our last lesson in all of the stats videos, and this one is over linear regression, linear model, residual, and correlation. And so this is going to be pretty quick. It's going to be a lot shorter than everything else, but basically one of the big thing you need to know is what residual is. And so residual, if you can see on this graph right here, this green dot that I drew is one of our data points on our scatter plot, and we use a best fit line, which is the white line that I've drawn, all the diagonal white line that I've drawn, and that's sort of a representation of our data. And we've seen a best fit line before in this class, so I think y'all already know what that is. But our residual for this data point would be the distance between the best fit line and the data point. So it would be this distance right here. And when it's below the line, it's negative, and when it's above the line, it's positive. So pretty much just whatever direction you move. If you move down, you're going to be negative. If you move up, you're going to be positive. Easy way to remember that. And we've already talked about correlation before because that was in our first unit when we were just looking at graphs of data. Okay, so the first question says, suppose y equals 2.5 minus 1.6x is the equation of a least squares regression line. So this is just asking us what is the value of the intercept. And so if you remember all the way back in algebra, when you're looking at just a graph of a line, you remember the form of y equals mx plus b. And so the m is the slope, and then the b is the y-intercept. And so for this one, the value of the y-intercept would be this 2.5 right here, right? Because that's not attached to the x. So the value of the intercept is 2.5. And then the value of the slope is going to be this negative 1.6 here. So negative 1.6 is the slope. And then what is the change in y if x increases by 1 unit? And so part C is just asking you, do you know what slope means? And so this is just saying that the change in y, if x increases by 1 unit, is negative 1.6 because that's what slope is. Part D says, use the given equation to predict y for x equals 4. And so what we would do here is y equals 2.5 minus 1.6. And then all we're going to do is plug in that value for x. So it'd be 4 here. And then this is going to come out to negative 3.9. And so that's how we would predict what we would find for data points. So if we draw that least squares regression line, and then we get an equation for it, and then we use that to predict all of our data points for whatever we're doing. So then one of the big things is that for the data that you made the graph off of, the range of data, you can't predict anything outside of that range of data. So let's say the range of data was 200 to 700 and whatever you're doing. Let's just say it's days. So you wouldn't be able to predict something that was 800 days, right? Because this is not inside this interval here. So that's basically, and you couldn't predict anything like 100 because it's outside of that interval. But you can predict something like 350 because that is inside of the interval. So that's a check. That's one of the key things about the least squares regression line and predicting the data points. Okay, so this part says, suppose we fit a regression line to predict the shelf life of an apple based on its weight. For a particular apple, we predict the shelf life to be 4.6 days. The apple's residual is negative 0.6 days. Did we over or underestimate the shelf life of the apple? So let's go in here, and I'm going to bold one of these points. So I'm going to say, let's use this point right here, right? And so it said the residual is negative 0.6. So this looks like something that would be about negative 0.6, right? And remember what I said earlier, that when you're moving down from the prediction line, it's negative. It's a negative value. So this is just asking us basically, did we over or underestimate the shelf life of the apple? And remember, our estimation would be this line. So our estimation for the point would be right here, and then the actual point is right here. So we overestimated on this. So overestimate. Okay. That one's pretty simple. All right, this is our last part. And so, like I said, this is going to be a really short video. This is going to be part of RStudio, but I'm not going to do it in RStudio because this is really basic, and I'm just going to write down the commands for you. So it says download this file and read the data into R. The problem below refers to the variables contained in that file. So for the first thing we need to do is plot y versus x. So what we will do is we'll put the plot there, and then we'll find the x variable and then the y variable. And so that'll make it look like just one of these graphs I drew up here. So it'll look similar to this graph. Yeah, but it won't have that line through it yet. So you'd have to draw that yourself. But so it wants us to find the form of the line, and the form of the line, which I don't have it pulled up, but it's linear, and the direction is there's no direction. So that means it's basically like straight across. And it's not really positive and it's not really negative. And so the correlation between x and y, so what you would do for this is you would say correlation and then the x variable and the y variable. And it turns out to be, for this one, it turns out to be 0.0108. And so part C asks us, is correlation an appropriate measure of the strength of the relationship between x and y? And here, one of the things is that yes, it is, and because it's a linear relationship. So if you have a non-linear relationship, you can't use correlation to appropriately measure the strength of the relationship. So yes, because it is linear, right? And so if you had something that was, let's say, that looked like this for the relationship, they might still have a strong correlation, but it's going to give you a bad value because when it looks for correlation, it's looking for a straight line. Okay, so part D says find the correlation between x and 5y plus 3. And so whenever you do anything like this, if you're doing anything to a variable, it's not going to matter. So the correlation is still going to be the same. It's still going to be this 0.0108. No matter what multiplication or addition operations you apply to each of these variables, is still going to come out with the same correlation between x and y. So that's one of the interesting facts to know. And that's all I've got for you. Thank you again for watching all these videos, and I hope you enjoyed it, and I hope I was able to help you. Have good luck in class, and thanks for watching.